Click the bell icon to get latest videos from Ekeeda.
Hello friends, today we will discuss about the synchronization technique in the Linux operating system. What are the modes and applies types to the synchronization exhibition? Linux used a non-preemptive kernel where a process cannot be preempted while running in the kernel. When a process cannot be preempted while running in the kernel, even if a higher priority process is available to run, the process that is running in the kernel should not be preempted. Prior to version 2.6, Linux uses a non-preemptive kernel which makes the processing in the kernel cannot be preempted. Even if a higher priority process is available to run, then the currently running process should not be preempted. But after the versions from 2.6, kernel Linux is fully preempted that the process running in the kernel can be preempted. Linux provides different mechanism for synchronization inside the kernel. Now, as there are simple instructions for the atomic versions of simple math operation that is provided inside the kernel, the simplest synchronization tool that is used as an integer atomic. The simplest synchronization tool that is used is an atomic integer. Now this integer can be represented by an opaque data type atomic T. As the name implies, this integer can be executed uninterruptedly or atomically. We are declaring an atomic T type variable counter and an integer value associated with it. Now we will see different type of operations that are performed within this counter. The atomic set function is used to pass the pointer to the counter and a value associated with it. Now it will set the value of the counter to 5. Here, using this atomic add function, we are adding 10 to the current value of the counter without passing the pointer to this counter. Using this atomic sub function, we are actually subtracting 4 from the pointer to the counter, that is the actual value of the counter. Atomic inc function is to increment whatever the value of the counter is with 1. Now the atomic read function will return the actual value and current that is stored in the counter, and it will be then consumed by the variable value. All these operations are sufficiently increasable or this integer variable updation like a counter updation. But it is only useful for this sort of scenarios. If there are several variables possible in a rest condition, then this integer type of synchronization might not useful. There we can use a mutex lock to provide and protect the critical section. A mutex lock should be acquired before entering the mutex section, that is known as a mutex lock call. When we are invoking the system call to mutex lock, then a mutex lock is acquired by the process which want to enter its critical section. After exiting from the critical section, the process will release the lock using the mutex unlock. Suppose a process wants to enter the critical section and requesting for a mutex lock function, but the critical section is used by another process, then it will put into sleep by that mutex lock function, again will be awakened when the owner system call to mutex unlock function. Linux also provides semaphores and mutex locks and the spin locks to provide synchronization between the threads. On SMP architecture, which is a multiprocessor architecture, the spin lock is the only way to synchronize between the threads. The kernel must use the spin lock only held for a shorter segment of code. Thus, on a single processor environment, this spin lock is often not useful. There we can use the disabling of kernel preemption without using the spin lock acquiring, and without using the spin lock releasing, we use the kernel preemption. Now, enabling kernel preemption and disabling kernel preemption can go in kernel Linux in a very interesting way. We use the preempt disable and preempt enable function. We use a preempt disable and preempt enable function for disabling and enable kernel preemption. The kernel is not preemptible when it is holding a lock, and this rule can be enforced by letting all the threads inform and getting a thread info structure of their own, which thread info structure contain a preempt count and a mutex lock. The preempt count is used to count the number of locks held by a task. Whenever a lock is acquired by a task or a thread, then the preempt count is incremented. And if the preempt count is greater than 0, then the kernel disable function is called by preamble disable. And this preempt disable function can thus allow disabling the kernel preemption as the kernel requiring thread is acquiring a lock. Upon getting released by the lock, the preempt count function is decremented. And when the function preempt count is 0, then the kernel can be enabled again its preemption by calling the preempt enable function. Spin locks along with disabling and enabling. Spin locks along with disabling and enabling this kernel preemption can be held only for a short duration of time. If the locking is done for a longer period of time, then semaphore must be more useful than these mechanisms. That is all for Linux synchronization. Thank you for watching this video. Stay tuned with Ekeeda and subscribe to Ekeeda.